Okay, this is going to be part one of developing with Puya. Before we get into that, I want to go over classes, which are super important. You will be using classes a lot, as well as variables and methods. And methods are functions within classes, so I hope you watch the variables and methods videos, or excuse me, variables and functions videos before this, because they are very important for what we're about to learn. We're going to go over classes first and then go into Puya. And then before we start Puya, I'll explain what you need to have downloaded. There are going to be some commands here in the terminal you only have to use once to have AlgoKit ready, as well as be able to deploy contracts and several other things that we're going to be working with. But for now, let's just go over classes and then we'll jump into that. So a class, you basically just start with class. And class is a built-in Python syntax. It's kind of like def, right? Before you start writing a function, you start with def. So same concept with class. When you're creating a class, use class, and then you make up, similar to a variable name, you can make up something. I'm just going to call it Archer because I like gamifying things. So just class Archer. And you don't need the open and shut parentheses. You may have seen me just put that in. You do not need that. So class Archer followed by a colon. And below here, we're going to define things about the Archer. So let's say arrows is equal to 5. So this Archer will have 5 arrows. And let's also say bow equipped. So whether or not he's holding his bow is equal to false. So these are the default attributes or details about the Archer class or Archer. And what we can do is we can create an object. And an object is an instantiation of a class, or technically anything, but in this situation, we're instantiating an object from the class Archer. So I'm going to say my Archer is equal to Archer. And this time we're going to use the open and shut parentheses because we're instantiating something, we're calling something. So we're calling the Archer class and we're saying, hey, give me one of these. Okay. And if I said my Archer, my second Archer is equal to Archer, these two would be completely separate objects of the same Archer class. So if I change something about the first Archer, those changes would not reflect in the second Archer. Okay, because they're separate instantiations of the same class. Okay, because they're assigned to two different variable names. Of course, if I used my Archer again, then this would override whatever information was here. So you'll get an idea of what I'm saying here when I give you some examples of modifying these attributes under Archer by saying, for example, my Archer dot arrows is equal to 4. So maybe he used an arrow, maybe he lost one. Now his arrows are 4. So when you and if you have IntelliSense installed, which we go over in the Python installation, when you hit dots after my Archer, it shows you these two. Ignore all this other stuff. You won't use most of the other stuff, but the top two here, you'll see are arrows and bow equipped. So if I print my arrows and print my Archer dot bow equipped, you'll see that we get the default values that we started with. So we get 5 and false. And if we do this again and I say my Archer dot arrows is equal to 4, as we were stating earlier, and I also say my Archer dot bow equipped is equal to true, or maybe this should be the other way around. He equips his bow and then somehow one arrow goes away. Maybe he's putting it onto the bow, who knows? This is very vague at the moment. But you'll see that now when we print the attributes, arrows and bow equipped, they're no longer 5 and false. You'll see here they're 4 and true because we changed these things here. Okay, we accessed the Archer object, the instantiated instance of the class Archer, our object here. And we changed some things about it. And now when we print it, these values are no longer corresponding to these. Once you instantiate it, nothing else will change here. This will always, so here, if I create my second Archer is equal to Archer, and I print my Archer dots arrows and print my Archer dots bow equipped, you'll see that since it's a brand new class, it still has the default values. Excuse me, my second Archer dot arrows and my second Archer dot bow equipped. I accidentally printed the first object twice. So you'll see, even though I adjusted these values for my Archer, this object here, when I create a second Archer, it still has the default values. And then if I print my Archer, the first one, dot arrows, and this is just so you can understand that there are two different instances, and we'll move on after this, you'll see that they are still the same, even though we instantiated a new class here. Let me make this a bit bigger. So initial declaration of what the class will be and its attributes, creation of an object, which is an instance of this class, adjusting that instance, printing the attributes, and here we create a new instance, we print those attributes, and then we print the original my Archer attributes. And you'll see these are two different objects. So changes to one does not affect the other. So let's say that, for example, you didn't want to input these values. You don't want to say arrows 5 or bow equipped false every time. What you can do is you can say here def init self x y, and we can put arrows and bow equipped here, and we learned about arguments and passing parameters into functions. And this has to be self, and this has to be self. And this is something you kind of just have to get a hang of. So by default, when we have the Archer class like this, it's initiating self. But when we want to customize, when we want to create a customized instantiation, we have to manually declare self in a method, an init method, and we have to define them like this. This is just the format. So instead of saying my Archer is equal to Archer, we will say Archer and let's say 10 and false. Okay, and now when we run this and print my Archer dot arrows and print my Archer dot bow equipped, you'll see that this instantiation of the object has a customized attributes. And we can do the same thing again. And here we'll say my second Archer. And if you want to know how to do that, how I just changed 3 variables at once, you basically just highlight whatever you want to change. So I'm going to double click this, and you're going to see it highlights all 3. That's by default if you have IntelliSense. Hold Control, hit D, and each time you hit D, it highlights another copy, and then you can just change it. And for this one, I'm going to put 15, and let's say his bow is equipped. And when I print this, you're going to see you have, yep, 2 different objects with 2 different attributes. Same attributes, different values for their attributes. So this is, and let's say here we want to create a method So let's say equip bow, and let's say bow equipped we always want to be false. So we're going to remove y. And all this is going to do is say it's going to, oh, we have to pass in self here. All this is going to do is set the value of bow equipped to true. And then I'm going to create another one, unequip bow, pass in self. And self is just referencing everything that encompasses the class, like these attributes here. So unequip bow, and we're going to say self.bowEquipped is equal to false. And let's create another one called def shoot arrow self, and self.arrows is minus equal to 1. So minus equal is another way to say is equal to self.arrows minus 1. But if you just want to put minus 1 here, you can use minus equal. Okay, you can do the same with plus equal. And we don't need two minuses. So now what we can do here, and we're only going to work with one instance, now that we understand that these are different objects, we're going to call these methods. So these methods don't take any arguments, only the first one does, but we removed whether or not the bow's equipped. By default, bow will be false, bow equipped. So all we need to do is pass in the number of arrows they start with. We're going to print the number of arrows they have and the bow equipped. So by default, this will be 10 and then false. Okay. And then here, we're going to say my archer dots equip bow. And we're going to call that because it's a function. So open and shut parentheses. And then we're going to print my archer dots bow equipped. Okay. And we're going to see how the function, which is a method in the archer class of our instantiated object, affects the attribute bow equipped. So let's see what happens. So initially we have 10 and false. And then you see when we call this function, it gets set to true because we're calling this function equip bow, which sets the bow equipped attribute to true. And then if I wanted to call unequip bow, you'll see the same effects. Bow equipped, let's print that. So it's going to be false. Okay, so we equip it, it's true. Unequip it, it's false. And let's say I want to shoot an arrow. So let's shoot an arrow afterwards. Shoot arrow. And then let's print my archer dots arrows. And you'll see here that arrows gets decremented by 1. And we learned about for loops. So if I say for I in range of 5, shoot arrow and prints how many arrows I have, you'll see it goes 9, 8, 7, 6, 5. So we shot 5 arrows, we have 5 left. So it's kind of not correct to have your bow unequipped and to still let your archer shoot arrows. So what we can put in here in shoot arrow is before we decrement, let's make sure, let's assert that self.bowEquipped is equal to, equal because we're comparing, not assigning a value, is equal to false, or no, excuse me, true. So the bow has to be equipped for arrows to shoot. And let's see what happens here. So we get an assertion error. So bow equipped becomes true when we equip bow, but right after we unequip the bow. And then we try to shoot the arrow 5 times. So this assert makes this function fail. And assert statements are used a lot in Puya. Because let's say, for example, I have a contract and it says, let's say it's a staking contract. And I want to set the contract, the user's balance in the contract how much they have staked to the amounts of an asset transfer that they made to the contract. So they send the contract 10 tokens, and then the contract says, okay, you have 10 tokens with the contract, and it writes it down, perhaps in a global or local state or an application box, one of the three methods of storage in a contract. So what if they didn't transfer to the contract? What if I make the argument like, hey, contract, look at this asset transfer that he's making as he's calling the contract and make sure he's sending 10 tokens. What if he is sending 10 tokens, but he's sending it to himself? But the contract only checks if it's an asset transfer. So little things like that. So asserts that the asset transfers receiver is the contract because they're staking with the contract. Assert that the token they're staking is for this staking pool. They can't stake finite for Nico token rewards. You know, you want to put in assert statements. So it doesn't make sense for me to let the user have their bow unequipped and then still shoot an arrow because that's not the way things should work. And that's how people find exploits. They are running around in a game with no bow equipped, but they're still shooting arrows. Maybe you're in a friendly zone and the bow's unequipped, but you can still shoot arrows. Right? So, and this is why you have to create these assert statements. And this is very similar to what an Arc4 contract will look like. If this doesn't look too confusing to you, if it does at first, that's normal. I bet the self is confusing you, as it always did me. But once you grasp this concept, this you just kind of have to remember, initialization. And then methods are just functions. And then a class you just kind of define at the top. And you put it all together, this is kind of what a smart contract looks like on AlgoLearn. Not exactly. There's a lot missing. But this is a good place to start. And I'm going to cut off here, and I'm going to prepare a simple Puya contract and go over installation with you right after this. So give me a few moments. I'll be right back. Okay, I'm back. So we're going to get into writing this, the equivalent of this code here in Puya as a smart contract on AlgoLearn. So there's a few things before we start. So firstly, if you don't have Visual Studio Code open right now, create a folder on your desktop called whatever you want, Puya Lesson 1 or My First Puya Lesson, My First Contract. Open Visual Studio Code. I would assume you have it installed from the previous videos. If you don't have Visual Studio Code, go to the website and download it. Open it up. You'll have a blank template. Just go to File, Open Folder, select the folder on your desktop you just made. You'll have a blank slate folder, paper with the plus icon, and you're going to create myarcher.py. And if you type from AlgoPy and it doesn't show up green and kind of try to, there's this pop-up that kind of indicates it's recognized. If that doesn't show up, then, well, there could be a myriad of issues. So first thing, you need Python installed, you need AlgoKit installed, and you need algoran-python installed. So for Python, we've done this in previous videos, but just because this is the first Puya video, I want to make sure everyone's starting on a good note. So Python, just Google Python, go to the website, go to downloads if you don't go to this default page, downloads, and then here you'll see download Python and then the current version. If you're not sure when you installed Python last, if it was like months ago or like a year ago, or even 2 months ago, I would still download this file, click this, and you're going to see if you have it installed, if you have Python set up, you're going to see this menu. I would like you to uninstall and reinstall if you're not really experienced with Python, especially with AlgoKit's kind of scaling with newer versions of Python. So just in case, if you're not sure, uninstall. And then when you reinstall, there's two checkboxes at the bottom. When you go to install, it says run with admin privileges, check that off, and then also add python.exe to path. Make sure you check that as well. It's not showing here because I already have everything installed, but make sure you do that. Once Python is installed, Visual Studio Code won't recognize it at first. So you'll have to close it and then open it again. And if you go down here and you type Python -- version, you will see your current version. For AlgoKit, you're going to want to type pip install AlgoKit in the terminal here and hit enter. And then for AlgoLearn Python, aka Puya, you're going to type pip install AlgoLearn - Python. And then you should be good to go. If this doesn't work, and when you go to type from AlgoPy, this doesn't show up, instead try using pip install pipx, then pipx install AlgoKit, and pipx install AlgoLearn - Python. That last one might not be needed actually. Try these two, and that should be good. And then if you still don't see it, try restarting your computer, or not your computer, but closing Visual Studio and opening it again. Restarting your computer is like last resort. If it's not working at that point, then your Visual Studio code might be messed up. You might have played with some settings. Down here, if it says undefined, you can click it. Right here, it says at the bottom, language mode, and then down here, you should see the version. If not, you can try to select it manually. It should give you options automatically here, so you could just click that. Otherwise, we're going to begin. So to start off, we have to import the arc4 contract class. So we're going to do class, similar to our original archer, class archer, and then we're going to pass in arc4 contract here. Okay, and then we're also going to do the init method as we did before and pass in self. Okay, so far everything's the same, except we're not going to pass in x when we initialize. I'm going to show you later why. And in Puya, I believe it's pretty strict with type annotations. So what that means is for return statements, you have to indicate what the function is going to return. So for example, if I was returning a string, or let's say hello, I would need to say I'm returning a string. Okay, and I think Puya is pretty strict about that. So that's not something we went over. This is going to return none, so we don't need to. So there's no return statement here. But just pay attention to this when you will get errors when you compile and you'll figure it out. But just letting you know, we're going to introduce that here, type annotation. Next up, we're going to do the arrows, I believe, and bow equipped. But we're going to start these off just as types. So self.arrows, and we're going to pass in local state. And that's because, sorry, one second. And that's because this information we're going to tie to a user's account information with the contract. So each person that interacts with this contract and opts in, they can have their own local state with the contract that tracks their archer. Similar to how we created our own archer each time. So we had my second archer before, but this is basically, think of it as an account creating a local state with an application. Someone creating their own instantiation of the class archer. So we're going to use local state, and we're going to pass in, what's going on here? I'm just going to quickly open a new window and reopen the folder because I'm not sure why it's doing that. Hold on one second. Okay, now it's green. I don't know why that happened. Visual Studio glitches out sometimes. Okay, good. So we're going to say local state, and we're going to, arrows is going to be an integer, but we're going to use uint64, and that needs to be imported. And then bow equipped is going to be a Boolean. And Puya allows you to use the regular bool class from Python, so we don't need to import that. Uh, let's see. And I'm going to add something else here just to show you later. Global state. And this is going to be something the contract tracks on its own. It's not restricted to a specific account. So self.archers created is equal to global state uint64, and we're going to set this to 0 initially. And here we're going to start our first method, which is equip bow. And it looks pretty simple here. It might look a little bit more complex because of all the functionality we're going to be adding and some of the constraints with the contract. So the first thing we're going to be adding is the ABI method. So from algopy.arc4 imports ABI method. And we're going to add this decorator here, which is just something that's used in compilation of the contract for Puya to know, like, hey, what is this method supposed to be? What standard is it? Are you accepting arguments? As opposed to a subroutine, it's just a function that runs. It's not part of a class, or it doesn't alter certain things. So decorators, you're going to get used to it. And we're going to select allow actions here because in this function, or I'll show you this later, the allow actions. So ABI method, and we're going to say def create archer. And we're going to pass in self and x. And because it's type annotation, we have to indicate that it's going to be an integer or a uint64, as Puya sees it. Okay, and we're going to return none for now. And here we're going to say self.arrows, and we're going to use index notation to kind of indicate who, and we're going to need to import transaction here. And transaction kind of has everything about the transaction that's occurring right now, which would be this application call. So transaction.sender would be whoever's sending this application call. There are also other traits like transaction.application ID, asset amount if it's an asset transfer, asset receiver or sender. We have if it was an asset configuration transaction, you could have the asset ID created, the fee of the current transaction. There's a lot of things, rounds. There's a lot you can do with this transaction class. So right now we're just accessing the sender of the current transaction. And we're going to say the local state for this account in this contract. We're going to have something called arrows, and we're going to set it to whatever number they give us, which is similar to here when we init. We have the number of arrows they selected to be the number of arrows for this instance of archer. So that's going to be X. And then we also want to set their bow equipped for this sender only to be false. And again, Puya supports the native booleans in Python. And then archers created, every time an archer is created, we're going to increment the global state. Actually, it's going to be dot value plus equal uint64 1. Okay, this is something we didn't include in our previous one. We didn't have number of archers, but we're going to add it in here. And this is independent of the current object. So this is tracked globally. So every archer that's created, the global state will be incremented by 1. And that's pretty much it for create archer. So what we can do here is try to compile this. So we're going to say algokit compile pi, and then we're going to type the name of our file. So my file is called myarcher.py. And let's see if we have any errors. And when you compile, you do need to save. So Control S, or you could go up here and hit File Save. And it looks like I'm good here. I do want to double check. Yeah, this is fine. Cool. And then you'll see an arc32.json pop up. This has the approval program. It has the create archer method and the argument it accepts, whether or not it returns anything. Void means it doesn't return anything. If I typed in here unt64, then I'd have to return a unt64 like X. And then when I compile, it'll say unt64 instead of void. But for now, we're just leaving it as none. And then you also have the approval.teal. So this is raw teal code. Some people enjoy pain and they write smart contracts in pure teal. It's a bit much for me. I've never found a reason to do this besides showing off or bragging rights, but I don't have that and don't do that. And clear state looks much simpler than approval.teal. It's always going to look like this for the most part, unless you're really going to get into advanced contract writing and create a custom clear state, which I haven't actually ever seen. This is fine for the most part. So what we're going to need to do next is actually launch this contract. And to launch the contract, we're going to need an account funded with testnet. And this is going to be pretty quick. So first things first, we're going to create a file called, just name it whatever you want. I'm calling it generateaccount.py. And you're going to need to pip install the py-algorand-SDK if you haven't already from previous videos. And once you've done that, so you would copy this, put it in here, and press enter. Once that's done, you're going to use the account library from the Algo SDK. There's a function called generateAccount. And what it does is it returns a private key and address as a tuple. And you can see that here. Oh gosh, it's doing it again. White text, but it's fine. So yeah, when you call this function, no arguments needed, it's going to return a tuple of 2 strings, which will be the private key and account address. And we're going to print this private key. We don't really, yeah, we'll need the address because we're going to use bank testnet to fund it manually. Perfect. So we have our private key. We're going to, so you double click here to highlight it and right click. And what you'll see is that you copied and pasted it, right? So when you right click, you copy and then Control V to paste. Same thing with the address. Double click, right click. You can also Control C, but you can't right click natively and get a little menu as you do with browsers and other desktops. So get the private key, go in here to the right left-hand side, click New File, .env, and this is where you're going to declare things that you want to keep private, like a private key. In the future, as a developer, you will probably use this as well. It's a way to put information in a file, .env, where others cannot access it or see it. So you could show people code, and they'll never see your .env. And I'll show you later how we access variables from .env and use them in the code. It's pretty trivial. It's not too bad. And then the address we don't need to save. I'm going to show you a function later, so we don't need this extra variable. But we are going to take the address for now. Go to the internet here, the browser. Search for bank testnet Algorand in Google or Bing. The first result should be Algorand dispenser. It will look like this. Copy and paste your address in here. Click I'm not a robot if you're not a robot. Dispense. And it's going to send you 10 Algorand to your wallet, your testnet wallet. Next thing we're going to need is Nodely as well. So we have an account funded with testnet. Now we need a way to connect to the testnet blockchain. So Google Nodely. You'll get this, nodely.io. Click Quick Start on the main page. And down here, you'll see Algorand endpoints. We're going to use the testnet row, the full Algod v2 API, so second column. And we're going to copy this. And we're going to go back to our env, and we're going to say, so algod token is going to be a blank string, so just 2 apostrophes. The algod server is going to be what we just copied between 2 apostrophes, like so, okay, because they're strings. For testnet, or not for testnet, but for Nodely, they don't have tokens because it's public, so there's no secret token you need to use. You just need the server, which is this URL. And now that we have a way to connect, we have a funded account. All we need now is, we also have a prepared contract that we can start calling to. What we need to do is launch the contract. So I'm going to create a new file, launch smart contract.py. This is going to be a little bit much. Once you write this once, or you can copy it from me, I don't mind. You can use it forever. You will only need to adjust 2 things, which will be the state schemas, which are simpler than you think. And that's pretty much it. And then you just run the code, as well as the approval file names. So I'm going to try to walk through it line by line. Yeah. So the first thing we're going to need is OS. And what OS does is it allows us to access our node token and our node server, as well as our private key, which are in here in the env file. So what we do is we say os.getEnv, and then we pass in the key. And by key, I mean the name of the variable here. So for token, we're going to put algod token. So copy and paste it. It's going to be a string. For port, or excuse me, node server, same thing. os.getEnv, string, algod server. And then private key, go in here, copy it. os.getEnv, private key. And now you don't have these things in your code. They could be private. You can show someone this code and they won't have access to these private things. Okay, for us to create a client, we're going to need to go into the v2 client.algod, import algod client from the Algo SDK library. And what we do is we say algod client. It's going to be equal to a instantiation of algod client with the token and the algod address. And these can be positional. You don't have to type in manually algod's address equals, algod token equals, and algod server, algod address. You don't have to do that. You can just put them in like this, positionally. And we can make sure it's working. We'll say status is equal to algod client dot status. And if we print status here, we should get the status, hopefully, of the network. Perfect. And you'll see here, testnet last round was, where is it? Last round, 44088.176. So this is working. Don't need the status again. And then we're going to need to get our address from our private key. So how do you get an address from a private key? The Algo SDK.accounts that we use to generate the account, they also have something called address from private key. It's a function. And you can say here, address, the user address, the AlgoLearn address is address from private key, and pass in the private key variable that we define here. Next up, we're going to need the params for the transaction. So we'll get that from the client. It's a method in the algod client, and this is needed with every transaction. And now we're going to need to get the approval.teal and clear.teal files here and bring them into this code somehow. And the way you do this is with a with loop, a with statement. So with open And we're going to say, actually, let's do it this way. Approval teal source is equal to archer.approval.teal. This is going to be a string. And the clear teal source is equal to archer.clear.teal. And now we're going to open the approval. It's going to be an F string. Approval teal source. And we're going to be reading as F. And approval teal, or actually we should name this approval teal file name. And clear teal file name. And then approval teal source is equal to f.read. And you can copy and paste this and just replace it with clear teal file name. And here we're just going to replace approval teal source with clear teal source. So now we have the approval and clear teal in our code. And next up, we're going to need to compile. So compiling is a method in the client. It's called algodclient.compile. And we're going to say the approval results. It's going to be algodclient.compile. And I know this is getting a little overwhelming. Just know that once you write this once, again, you won't need to write it again. And if you want to skip this part, to be honest, you can. The code will be on the website where you're watching the video. Unless you're on YouTube, you would need to go to either the GitHub or the AlgoLearn website. But if you want to follow through, so you kind of get an understanding of what's going on, we're going to continue here. So we're going to pass in the approval teal source. And then what this will give us back, and I guess I'll just print this. If it's not an object, I might be able to explain it a little better. Yeah. So it gives you a hash, and then it gives you this result. And the result is the base64 encoded string. In fact, it won't match this actually. But this is what you're going to use, the base64 encoded string, when you pass it in to an application creation transaction. So the base64, the decoded bytes of the base64 encoded approval teal source. So what we need here, the approval program is going to be, and we can import, we have to import base64 here, or better yet, from base64, import v64 decode. And what this does is it decodes a base64 encoded string into bytes, which is needed for the application creation transaction. So approval program is going to be equal to approval results, and we learned about key notation. So we need results here in this dictionary. So we're going to pass in results. And of course, we need to base64 decode this, because we need the bytes version of this base64 encoded string. And we're going to do the same thing with the clear teal source. So the only difference is we'll call it clear result. And a clear program. So I'm going to just highlight this, Control D, and write clear. Okay, that should be good. And the next thing we're going to need is the state schema. And this is how you tell the transaction, the application creation transaction, how many keys you want to allow your application to have globally and locally. For global states, you can have up to 64 keys. And for local states, you can have up to, I believe, 16 keys. When you declare the state schemas, and I'll show you now. So let's do the global schema. They want you to clarify the number of integers and the number of bytes the contract is going to use for global state. If you want, you can just put 32 if you'd like. Positional arguments might be better here. Just split it equally, the 64 keys, 32 integers and 32 bytes. If you want to actually have it be accurate, our contract, we only have one global state and it's an integer. So we're only going to need one. And we don't need any byte slices. And then our local schema is going to need a bit more. And if we look at our contract, we're going to have two unt64s. Oh, hold on a sec. Yes. So we only have one unt64 for the local state, but a bool actually evaluates to either a 0 or 1. So technically this would be another integer. So we need two integer keys. So in num uints, number of integers the contract will have as keys in the local state, the number will be 2. And byte slices, we don't need any. And now we can form our application creation transaction. So in the transaction library of the Algo SDK, state schema, and also they have application create transaction. And we're going to say our transaction is equal to, or you can just put TX for shorthand, is equal to an application creation transaction class. And we're going to start putting things in here. I personally like to press enter a few times and put all these arguments within. So sender is going to be, so the first thing they ask you for is the sender. The sender is going to be the address. Okay, the account that we're using. SP is suggested parameters. We have that here, params. So next up, SP is equal params. After that, they want onComplete. When you create contracts, probably in the entirety of AlgoLearn, we're probably just going to use onComplete no-op. So in the transaction library, we're going to import onComplete. And I'm going to explain to you what no-op and opt-in, the differences are. OnComplete dots no-op OC. So no-op OC basically means when someone calls this contract, they will not need to opt in. If you have opt-in OC, they will have to opt in. Or not they will or won't, but this transaction will or won't opt in to the contract at the same time as it is being called. So we don't need our account to opt in when we create the application. Okay. If you want to implement something like that, you can change that to opt-in, and I'll show you how to implement that later. In the contract, you have to indicate in the ABI method decorator whether or not it will accept opt-ins or not. By default, it only accepts no-op. Next up, it wants the approval program and clear program, and we have that compiled here. Approval program and clear program, compiled and decoded. So we're going to say the approval program is equal to the approval program, and the clear program is equal to the clear program. And the only other things we need will be the global schema and local schema. Yeah, nothing else will be needed. So global schema is equal to our global schema, and local schema is equal to our local schema. And we are done with creating the application call or application creation transaction. So all we need to do, and we've signed transactions before, it's going to be transaction, tx. This object that we created, it has a method called sign. And we're going to pass in our private key, which we defined earlier here, which we're getting from the env file. And once we have a signed transaction, I'm going to show you a try except loop. So we're going to try to get the transaction ID, which is the result of algoClient.send transaction, single transaction. And we're going to pass in the signed transaction. If it fails, which it probably won't, but if you run out of AlgoLearn, failed due to, and what you can add here is accept exception as E, failed due to, and just put the E in here. So when you print, it's going to say failed due to and the reason why it failed. And then we're going to print the transaction ID. This is an F string. And then we're also going to want to get the application ID. So I'm going to import wait for confirmation. So we can wait for the transaction to complete. Even though you don't need to wait to get the transaction ID, I want to wait for the transaction to pass in the algoClient and the transaction ID. I want to wait for it to complete so that I can get the information about the transaction here using the pending transaction info method of the algoClient, and we're going to pass in the transaction ID. And it's going to return a dictionary, and the application ID that we created is going to be in transaction info in a key called application-index. And then I'm going to print here application ID, and I'm going to punch in application ID here. And then we don't really need the app address, but I do add this in. There's a library called logic. And logic will basically translate in, so get application address. You just input the app ID, and it'll give you the address of the application. So I usually print this anyways. Even though we won't be needing it here, it's good to have as a default template. Oh, and let's use an F string. Okay. And if we run this code with our funded account, hopefully there will be no errors. Yep, we get a transaction ID, application ID, and an application address. For now, we just need the application ID. We're going to punch that in here. And we're going to get started with calling our contract and getting this to work.